Hello everyone, welcome back to Maths class, Chapter 9 Matrices, the continued part of exercise 9C. Question number 13. In this question, matrix A is given with the elements -1, 1, A, B and the condition is said that A square is equal to I. What is I? I is a unit matrix. As it is equated, A square is equal to I, it gives an idea that the order of A square is equal to the order of I. By keeping this equality in mind, we need to find the two unknown values A and B. Let us define the values for I unit matrix, which is a diagonal matrix which contains 1 in the principal diagonal. So, I is defined as 1 0 0 1 of the order of the matrix 2 by 2. Let us calculate A square in the first step, that is A into A. In the second step, equate the elements of A square to the corresponding elements of I, hence we can find the unknown values A and B. So, this problem should be solved in two steps. Let us consider the first step. A square is equal to matrix A into A. As both the matrices are of the order 2 by 2, we can apply the same rule: first row, first column, first row, second column, second row, first column and second row, second column. Hence, A square will be equal to 1 plus A minus 1 plus B minus A plus AB, A plus B square. Here we can find the terms in the form of an equation. Let us equate this value to the matrix I. Consider the corresponding elements. Let us consider the first element. 1 plus A is equal to 1. Hence, value of A will be equal to 0. Consider the second element. Minus 1 plus B is equal to 0. Hence, B will be equal to 1. Or you can take the corresponding elements of third and fourth, but in third and fourth we need to substitute the value of A and B and hence its value will be equal to 0 or 1. The third and fourth element you can just cross check, as it is asked to calculate only the value of A and B. A is 0, B is equal to 1. In question number 14, three matrices are given A, B and C. All the three matrices are of order 2 by 2. There are two sub-questions that we need to show that A of B plus C is equal to AB plus AC. Second question, B minus A of C is equal to BC minus AC. So by observing these sub-questions, we can know that the first sub-question says the distributive property of multiplication over addition, and the second property says distributive property of multiplication over subtraction. If we can prove these two conditions, by this we can also say that the distributive property of multiplication over addition or subtraction holds good with the help for matrices also. Let us solve and let us decide whether it's going to hold good or not. So how to solve this problem? So first consider the sub-question. In the sub-question, in the first step calculate B plus C. In the second step, calculate A into B plus C. Mark it as result number 1. And consider the right hand side. First calculate A into B, then calculate A into C, then add the corresponding elements of AB plus AC and mark that result as result number 2 and compare result 1 and result 2 and give your solution. Let us proceed with the solution. First step, B plus C. Consider all the elements of B and C corresponding elements. Try to add here. So I have taken complete A of B plus C in one step. You can just note down for B plus C there is a bracket over here, and shall we add B plus C now? 2 plus 1 is 3, 3 plus 4 is 7, 4 plus 0 is 4, 1 plus 2 is 3. So this is A and this is B plus C. Let us multiply these two corresponding elements. Both are of the order 2 by 2. Hence apply the same rule. Then the result will be equal to 10, 17, 0, 0. Mark it as result number 1. This is the result of left hand side. Let us move on to the right hand side. As we discussed, first step is to calculate the product of A and B. A is also of the matrix 2 by 2, B is also of the order 2 by 2. Hence, the product of AB results as 8, 7, 0, 0. In the next step, calculate the product of A and C, that is 2, 10, 0, 0. After calculating the product of AB and AC, add the corresponding elements of AB and AC. It results as 10, 17, 0, 0. Mark it as result number 2. This is the result for the values given on the right hand side. Now, if we compare the values on left hand side and right hand side, all the corresponding elements are equal. Hence, we can say that A of B plus C is equal to AB plus AC. With the solution of this problem, we can say that distributive property of multiplication holds good with matrices. The sub question 2. Consider the left hand side B minus A of C. First subtract B minus A. It results as 0, 2, 4, 1. And when you multiply this result with matrix C, it results as 0, 4, 4, 18. Just mark it as result number 1. Move to the right hand side. Calculate the product of B and C. The product of B and C, as both the matrices are of the order 2 by 2, it results as 2, 14, 4, 18, and the next product is the product of A and C. It results as 2, 10, 0, 0. We need to find out the difference of BC and AC. So, the difference of BC and AC will be equal to 0, 4, 4, 18. So, in sub question 2 also, the values on the left hand side are equal to the values on the right hand side. Hence, we can say that B minus A of C is equal to BC minus AC. By this, we can also say that distributive property of multiplication or subtraction holds good with the help for the matrices problems. So, question number 15. Here, this is a simple question. You will be able to find a solution, I hope, children. So, three matrices are given A, B and C. We need to simplify A square plus BC. So, three steps to be followed. First step, A square, A into A. Second step, BC, B into C. And in the third step, sum of A square and BC. So, as A is of the order 2 by 2, it results as 9849, that is the value of A square. Then B into C, both are of the order 2 by 2. So, it results as minus 3440. Then calculate its sum. A square plus BC is equal to 9849 plus minus 3440. Add the corresponding elements. 9 minus 3 is 6, 8 plus 4 is 12, 4 plus 4 is 8 and 9 plus 0 is 9. So, by this we have completed question number 15. Before we move on to question number 16, let us learn little more concept related to the multiplication of matrices. Please observe this given slide properly, children. Till now, we have done the multiplication of the matrices which are of the same order. The confusion creates when they are of different order. So, how to find out what order to be maintained while calculating the product? As we started multiplication, it was already intimated that if and only if the number of columns in the first matrix are equal to the number of rows in the second matrix, the multiplication process can be possible. So, if we consider the order of the matrix as m into n, that is the first matrix, and the second matrix is of the order n into p. You can note down here. Here number of columns is n, here number of rows is n. Then only we can do the multiplication A into B. It results as m into P. So, the order of the product, that is resulting matrix, will be always equal to number of rows of the first matrix and with the order of number of columns in the second matrix. So when we do the multiplication with different order of the given matrices, we have to be very careful, and before itself in prior we should know that what is the order of the resulting matrix. So here is a clue for you, just go through with this children. Matrix A is of order 2 by 2, matrix B is of order 2 by 1. You can note down here, number of columns is equal to number of rows, it is 2 same. So after doing the multiplication of A and B, AB, the product will be of the order 2 by 1. So if and only if A is of the order m into n, and if B is of the order n into p, then AB, it results as m into p. Always the product resulting matrix will be of the order equal to number of rows of the first matrix with number of columns of the second matrix. So in the beginning, as a practice and to make it perfect, let us write this step for few problems. Once you are comfortable with this, you can skip this step. Okay, let us move on to question number 16. Before that, let us observe some more examples here. A is of the order 3 by 5, B is of the order 5 by 2. 5 and 5 are same. Number of columns, number of rows. Number of columns of first matrix, number of rows of second matrix. Hence, what will be the order of the product AB? It is 3 into 2. Similarly, consider one more example. Matrix A is of the order 4 by 3. Matrix B is of the order 3 by 2. So, first matrix number of columns is 3. Second matrix. Question number 16. Here we need to solve for x and y. The first matrix is of order 2 by 2 and the second matrix is of the order 2 by 1. So, in this problem already it is given that the product which is on the left hand side, this is equal to the value of the right hand side. Hence, we can easily identify that after calculating the product of the given two matrices on the left hand side, the resulting matrix will also be of the order 2 by 1. But once we will cross check and verify like this. Consider the first matrix of order 2 by 2, second matrix is of 2 by 1, hence the product will also be equal to 2 by 1. Just identify how the number of rows and number of columns are mentioned over here. Then the resultant matrix will be of the order first row, first column, second row, first column. So while doing the multiplication, the variables x and y are there, plus and minus values are there. Be very careful and do it slowly, single step also. Don't skip a single step. Complete all the steps according to the given instructions. So when we multiply the matrix of order 2 by 2 with the order of the matrix 2 by 1, the resulting matrix will also be equal to 2 by 1. Here we have got the solution as 2x plus 5y and 5x plus 2y. This should be equal to minus 7 and 14. Let us equate the corresponding elements. When we are calculating this, 2x plus 5y is equal to minus 7, 5x plus 2y is equal to 14. You can identify that this problem can be solved only with simultaneous linear equation. Solution is not given. Equations are equated to the given values. Solve it, eliminate x and find out y, or eliminate y and find out x, and hence you can find the value of x and y. Don't skip the step, children. You have to do the solution with the simultaneous linear equation. Let me move on to the sub question 2. Here the first matrix is of order 1 by 2, 1 row 2 column, and the second matrix is also of the order 2 by 2, 2 rows and 2 columns, and hence the product will be equal to 1 row 2 columns. Once the multiplication process is completed, how the multiplication should be done? First row, first column, first row, second column. That's all. Only one row. First row, first column, first row, second column. It results as x minus y minus 8 minus 2y minus 8. This is equal to minus 7 minus 11. equate the corresponding elements. Let us equate the first element. X minus y minus 8 is equal to minus 7. Hence, it is equated as x minus y is equal to 1. Here, we cannot continue with this. Why? Because x and y, both the values are unknown. So, let us move on to the second term. Minus 2y minus 8 is equal to minus 11. Hence, the value of y will be equal to 3 by 2. So, substitute the value of y is equal to 3 by 2 in the first equation and find out the value of x as 5 by 2. X is 5 by 2, y is 3 by 2. And sub question 3. In the sub question 3, it is given that first we need to find out the product of these two matrices of order 2 by 2 and 2 by 1. It results as 2 by 1. Plus adds sum, plus symbol says it is sum. What matrices should be added? It should be added with 3 into minus 2 and 3 into 1. So do the steps accordingly, children. In the first step itself, it is continuously done over here. So first, this is the product of these two matrices. Plus is kept as it is. This matrix minus 2 and 1 is multiplied with the real number 3. 3 into minus 2 is minus 6 and 3 ones are 3. This is equal to 2 into y, 2y, 2 3s are 6. The value after calculating the product is equal to 2 and the other one is minus 3 plus 2x. So add these two corresponding elements. Hence, the value of x will be equal to 3 and y will be equal to minus 2. Try to do the simplification step by step. Again, I am reminding you the values of x and y. Be very much careful. So, in the slide also, into sometimes it represents as x. So, go through it very much carefully, which is into and which is x. Try to differentiate and hence find the value of x and y. By this, we have completed problems up to question number 16. We'll continue with the next class with the remaining problems. Thank you, children. Have a nice day.